Hello everyone. This is the first video on the chapter 2, that is sequence and series. We start with the chapter 2. Here we study first the properties of the sequence when we say that the sequence is convergent. Later on we move on to the concept of series. Then we think about some tests that will be used to examine the convergence and divergence of the series. However, let me know what exactly the sequences are. See, sequence means, first of all, it's a function from natural number to a field. If I consider the field is real, then we say that it's an real sequence. And if the field is complex, if f is a function from natural numbers to complex, then we say that it's an complex sequence. For example, if I give xn equals to 1 by n, or else xn equals to n. So as we know, the domain is natural number and the codomain is real number or complex number. So what we say if n is equals to 1? If I take n is equals to 1, then 1 by n will go to what? 1. If n is equals to 2, it will go to 1 by 2. For n is equals to 3, it will go to 1 by 3. 4 will go to 1 by 4. That means this is 0.5, 0.33, 0.25. All these are real numbers. So it's a function from natural numbers to real number. Is the definition is clear? So a real sequence is a function from natural number to R, whereas a complex sequence is a function from natural number to C. Then we move on to what is the convergence, notion of convergent sequence. See, for example, I will consider the same example 1 by n. We'll just take the domain is n and the codomain is r. If I consider the real line, I will try to plot this in the real line. For n is equals to 1, it is. So this is the interval 0 to 1. For n is equals to 1, it is 1, that is x1 is 1. For n is equals to 2, it is half. For n is equals to 3, it is 1 by 3, that is x3. It goes on and on, then it approaches 0. As n tends to infinity, xn will approach 0. In the sense, if you stand at 0 and try to draw how much small ball you want, ಚಿಕ್ಕದೊಂದು epsilon radius to ball ಹಾಕೊಳ್ಳಿ, 0 plus epsilon, 0 minus epsilon. In this ball, a finitely many are left out and all the other fellows will be within this ball. Then 0 is called the limit of the sequence, or else xn equals to 1 by n converges to 0. Or else I can say it as, I will just try to write this. Let us stand at 0. Okay, we are here now. and let us travel a distance of epsilon, however small we want. So let me say, sir, myself and you are here and we will walk for a while. The radius is epsilon, and again we will come back here and we will walk here also, epsilon distance. Let us travel a distance of epsilon from both the ends of 0. That means towards left we will walk epsilon, and towards left of 0 we will walk epsilon, towards the right of 0 we will walk epsilon distance. Then if m tail of the sequence, what do you mean by m tail? M tail means x1, x2, x3, xm, xm plus 1, xm plus 2. This will be the terms of the sequence. Will you agree? M tail means what? So this is the sequence. M tail means what? M tail means you cut the sequence at this stage. At xm you cut it. Then what else left? Xm plus 1, xm plus 2, so on. This is called as M tail. After mth stage, what else left out? That is called as M tail. So M tail of the sequence means it is equals to xm plus 1, xm plus 2, so on. So this M tail lies in our journey. What is our journey? 0, epsilon and minus epsilon. This is our journey. In this particular journey, that M tail should be there. That means how many fellows are left out? 1, 2, 3, M are left out. After that, everyone are here. Is it clear? In our journey, if lies in our journey, then the point where we stood at 0, or else where we started. Is the limit of the sequence. Then 0 is the limit of this sequence. In other words, let me put mathematically. We say the sequence xn converges to L if the distance between xn and L can be made very small, negligibly small. Epsilon will be given. So I will give you an epsilon. Then you need to travel that much distance. For all n greater than or equals to, okay, there exists a stage n such that xn minus L is less than epsilon for all n greater than or equals to n. What else it says? You need to understand this definition in an intuitive way. See, x1, x2, x3, xm. After xm, xm plus 1, xm plus 2, xm plus 3. This is called M tail, right? Where this M tail lies? M tail lies in this epsilon bar. That means how many fellows are left out? Finitely many are left out. Here also same thing. After n, that means n tail. This is a stage n. Instead of m, I am taking it as n itself. So after this xm plus 1. M plus 1 is greater than n. M plus 2 is greater than n. M plus 3 is greater than n. After that stage, every fellows are in that epsilon bar. If that happens, we say that xn converges to L. You can look to this example. Xn equals to 1 by n. What else happened here? See, first stage is this, second stage is this, third stage is this, 1 by 4 is somewhere here. Likewise, once you go, let me say after some 56 stage, you are very near to 0. If you are very near to 0, then you can say xn converges to 0. Getting my point? It is approaching 0. However small radius you draw, you can find infinitely many elements of that sequence. Only finitely many should be left out. That is called as convergence of the sequence. Is the idea is clear? Next is, what is an bounded sequence? A sequence is said to be bounded if an is less than or equals to k for all n. That means you can find a real number such that every element is less than that, modulus of that. Then we say that an is bounded. Bounded below means k should be less than or equals to an. Bounded above, an is less than or equals to k. For example, 1 by n, it is bounded above by 1, bounded below by 0. Is it clear? Or else xn equals to, or else an equals to minus 1. So the sequence will look like. So it is unbounded below but bounded above. Bounded above by minus 1. An equals to n. It is bounded below, unbounded above. Is it clear? Next result is, if xn is convergent, that is, let me say xn converges to L, then L is unique. That means limit of the convergent sequence is unique. Second is, if xn is convergent, then this implies xn is bounded. But the converse need not be true. That is, if xn is bounded, it need not be convergent. Example is xn equals to minus 1 to the power n. See, this is bounded above by 1 and bounded below by minus 1. So xn is less than or equals to 1. But this is not convergent. We will look after this why it is not convergent. Next is how to find supremum of the sequence. In order to find the supremum of the sequence, find supremum of the range set. Is it clear? If you find the supremum of the range set, that is equals to finding the supremum of the sequence. Then I have one more remark here. Supremum and infimum of the range set it is equals to supremum and infimum of the sequence. Next remark is this you need to observe carefully. See, what is the range set first of all? Range set means already we know a sequence is a function from natural number to real number, because we are bothered about the real sequences. That is, let me say this is xn. For n is equals to 1, it will go to x1, x2, x3, likewise you will get. So how many members are here? How many members are assigned? That is called the range. For example, xn equals to minus 1 to the power n. What is x1? What is x2, x3? Find all this. x1 is minus 1, x2 is 1, x3 is minus 1, x4 is 1. So what is the range set? Range set is 1 and minus 1. Is it clear? Now I will give you one remark. See, if the range of the sequence is finite, then xn equals to k for infinitely many n. It means what? To be very precise, so here you have x1, x2, it goes on and on, right? It is infinite. Now I am telling range set is finite. Let me say the same example. Range set, how many elements are there? 2 elements are there. That means finite, right? 1 and minus 1. So x1 went for minus 1, x2 went for 1, x3 went for minus 1, x4 went for 1, x5 is assigned to minus 1, x6 is assigned to, so that means x2n is assigned to minus 1, x2n plus 1 is assigned to minus 1. So x2n is for plus 1, x2n plus 1 is for minus 1. So range of the sequence is finite. Range set is finite. This is the range. Then whether this is agreeing, for how many values this is equals to 1? For x2 it is equals to 1, for x4 it is equals to 1, for x6 it is equals to 1, for x8 it is equals to 1. That means for infinitely many values that is equals to k. K here is 1. But the converse need not be true. What is the converse? Converse is, see, if this happens, then this, that is P implies Q. What is the converse? Whether Q implies P. Need not be. Why? I will try to give an example. So let me define xn to be 1 if n is prime and n otherwise. Now what will happen to the sequence? What is x1, x2, x3, x4, x5, x6, x7? Okay, if I write it likewise, x1 will be, see, if n is prime it will take 1, if n is not prime it will take 1 only. x2, 2 is prime, so it is 1. 3 is prime, it is 1. x4, 4 is not prime, so it will be 4. x5, 5 is prime, so it will be 1. 6 is there, it is not prime, so it will be taking 6. 7, that means it is prime, it will take 1. 8 it will be 8 only. 9 is not prime, so 9. 10, 11 is prime, so 1. 12 is 12 only. 13 is 1. 14 is 14. If I take x 15, 15 is not prime, so 15. 16, then 17 is 1. For 18 it is 18. Then again 19, then 20, 21, 22, 23, right? Now look to this. How many? Likewise it goes on and on. For every prime you will get 1. So how many primes are there? Already we know there are infinitely many primes. So your range set is, getting my point? Converse need not be true means whether Q implies P. Xn equals to K. So whenever P is prime, XP equals to 1. How many primes are there? Infinitely many. That means Xn equals to K for infinitely many such n. Is it getting my point? This point. Whether it implies P, whether the range set is finite. Look to this range set. Range set is not finite. 4, 6, 8, it's going on and on. Getting my point? So that means range set need not be finite. Range set is infinite here. This idea is clear? Please try to understand this, because in the options while giving the options, those options will be concentrated. So we cannot tick. We should know what's happening. First you need to know what exactly the range set is, then we can think about those things. Next is this. We saw this, we did everything. What else I am discussing now in our UG level. So if limit of an as n tends to infinity is a, and limit of bn as n tends to infinity is b, then limit of n tending to infinity an plus bn is a plus b. Limit of n tending to infinity an into bn will be ab. Limit of n tending to infinity an by bn equals to a by b, provided bn is non-zero and b is also non-zero. So now whether these, we know this, if this happens then this will happen, that is P implies Q, but the converse need not be true. That is the point here. P implies Q, agree, but Q does not implies need not. Why? I'll try to give an example. See, if an is converging to A and Bn is converging to B, this will agree always, and this will agree and this will agree. But the converse, that is, if this is convergent, can we say individually it is convergent? That is, if limit of an plus bn, if I say this is Cn, that is Cn is the sequence of an plus bn, if Cn is convergent, can I say individually they will converge? Need not be. Example is, for the first one, I will give an is equals to n, bn is equals to minus n. What is an plus bn? So this is 0. So what is limit of an plus bn? It is 0. But an, it is divergent. Bn, it is also divergent. That means converse need not be true. Is it clear? If limit of an is a and limit of bn is b, this will work. But if this is working, if an plus bn is, if you can find it is convergent, we cannot claim this is convergent. Similarly for the second one, an minus an into bn. See, an equals to minus 1 power n. Bn also I will give minus 1 power n. What is an into bn? It is minus 1 power 2n. It is nothing but 1. It's a constant sequence. It is convergent. But an is not convergent. An is not convergent. Bn is not convergent. That means converse need not be true. Is it clear? This should be taken care. Similarly, you can think about third one, an by bn. If an is convergent, you can give an equals to n and bn is equals to minus n. What is an by bn? It is minus 1. See, this is a constant sequence. So limit of n tending to infinity, an by bn is what? Since it is constant, first term is 1 minus 1, second term is minus 1, so it converges to minus 1. But whether individually they are convergent, an is diverging to infinity, bn is diverging to minus infinity. That means converse need not hold. Is that clear? Next we will think about some standard results. The first result is limit of 1 by n to the power p is 0, where p is positive. We can prove this, but I am not going to prove all those things. And if p is greater than 0, nth root of p is always tending to 1 as n tends to infinity. Similarly, you can say nth root of n will also tend to 1. I'll just try to prove why it will look likewise. Let me say xn is nth root of n, that is n by 1 by n. That is a. Let me say a is this. So what is taking log on both sides? Log a equals to 1 by n into log n. What will happen if n tends to infinity? Say as n tends to infinity, log infinity is infinity, infinity by infinity. So it is an indeterminate form. So we will apply L'Hopital's rule. If I apply L'Hopital's rule, n tends to infinity, log n will be 1 by n, denominator is 1. As n tends to infinity, this will go to 0. That means log a is 0. This implies a is nothing but 1. That is limit of n tending to infinity, nth root of n is 1. Fourth result is n alpha 1 plus p to the power n, where alpha is positive and p is positive. Alpha can be any real number actually, but p must be positive. What else I am telling here? See, this is exponentially growing. Some n to the power alpha is there. 1 plus p whole to the power n. You need to concentrate on this n. N is in the power, so that's why exponentially the denominator is increasing. If the denominator value increases exponentially, then this value will be larger. So if this value is larger, whatever the value here, n to the power alpha, the denominator will dominate the numerator. That means it will go to 0. This idea is clear. So this we will use in between improving some standard problems. So 1, 2, 3 and 4. You need to remember these 4 things. Is it clear? Thank you. We will just think about some properties of the sequence in the next class and the Cauchy sequence in the next class. Thank you so much.